Today we are going to discuss about the domain of the function. Domain of the function. The first problem, f of x equal to 1 by x. F of x equal to 1 by x. F of x is belongs to capital R. Here it is a what are the variable for x. Now we have to find. So here it is a what is the domain of the, now I am taking the one mixer grinder. If you put apples, we will get the apple juice. If you put pineapple, we will get the pineapple juice. So whatever it is a input is called the domain of the function. Whatever we are getting the output, that is known as the range of the function. So we cannot put which is not, it is harmful for the grinder. So here it is a, we are unable to put x equal to 0 here. Why? Denominator 0 is not acceptable. So here it is a x is not equal to 0. So we can put any value for x, but we are unable to put x equal to 0. So what is the domain of the function? It is r minus 0. So x is belongs to r minus 0. So the domain of f of x is r minus 0. Now second one, I am taking f of x equal to 1 by x minus 1. Here also it is a 1 by x. Denominator is not acceptable 0. So for f of x is belongs to all the real number. Here x minus 1 should not be equal to 0. That means x minus 1 is not equal to 0. From this x is not equal to 1. So except 1 all the real numbers. Except 1 all the real numbers. So x is belongs to r minus 1. Now I am taking one more example. F of x equal to 1 by x minus 3. That is f of x is belongs to capital R. From that x minus 3 is not equal to 0. So that means x is not equal to 3. So x is not equal to 3 means except 3 remaining all the real numbers. So that means x is belongs to r minus 3. Now I am taking the one more example. F of x equal to 1 by x plus 4. 1 by x plus 4. So for f of x belongs to capital R, here also same condition, denominator is not equal to 0. So x plus 4 is not equal to 0. So that from that x is not equal to minus 4. So therefore x is belongs to r minus 4. Next example, fifth one, f of x is equal to 1 by x minus 1 into x minus 2. So here also f of x belongs to capital R. For x belongs to capital R, denominator should not be equal to 0. So that is x minus 1 into x minus 2 is not equal to 0. So from this x minus 1 is not equal to 0, or x minus 2 is not equal to 0. When it is equal to 0, if any one of them should be equal to 0. So that means x minus 1 is equal to 0 or x minus 2 equal to 0, then the product should be equal to 0. If x minus 1 into x minus 2 is not equal to 0 means x minus 1 is not equal to 0 or x minus 2 is not equal to 0. So from this and we are getting here and x minus 1 is not equal to 0 and x minus 2 is not equal to 0. From this x is not equal to 1 and x is not equal to 2. So x is not equal to 1 and x is not equal to 2. That means except 1 and 2 remain all the real numbers. So x is belongs to capital R. We have to eliminate these two, 1 comma 2. Next example, f of x equal to 1 by x plus 2 into x minus 4. For f of x belongs to capital R, here denominator is not equal to 0. X plus 2 into x minus 4 is not equal to 0. That means x plus 2 is not equal to 0 and x minus 4 is not equal to 0. Here x not equal to minus 2 and x is not equal to 4. So x value, the values of x except to minus 2 and 4. That means x belongs to all the real numbers except to minus 2 comma 4. Next, f of x is equal to 1 by x minus 4 into x plus 10. F of x is belongs to capital R. X minus 4 into x plus 10 is not equal to 0. So this is x minus 4 is equal to 0 and x plus 10 is not equal to 0. X is not equal to 4 and x is not equal to minus 10. So except 4 and minus 10. So x is belongs to r minus 4 comma minus 10. So the domain of f of x, the domain of f is r minus 4 comma minus 10. Next problem, 7th. F of x is equal to 1 by x square minus 4. F of x equal to 1 by x square minus 4. So f of x is belongs to capital R. X square minus 4 is not equal to 0. So x square minus 4 we can write it as x square minus 2 square is not equal to 0. So that means x minus 2 into x plus 2 is not equal to 0. So that means x minus 2 is not equal to 0 and x plus 2 is not equal to 0. From that x is not equal to 2 and x is not equal to minus 2. So except 2 and minus 2, so remaining all the real numbers. So x is belongs to r minus 2 comma minus 2. So therefore the domain of f is r minus 2 comma 2. So next, 8th problem, f of x equal to 1 by x square minus 9. F of x is belongs to capital R. X square minus 9 is not equal to 0. So from this, x square minus 3 square is not equal to 0. So that means x minus 3 into x plus 3 is not equal to 0. That means x minus 3 is not equal to 0, x plus 3 is not equal to 0. From this, x is not equal to x minus 3 is not equal to 0 means x is not equal to 3 and x is not equal to minus 3. So except all the real numbers except to 3 and minus 3. So x is belongs to all the real numbers except to minus 3 comma 3. So therefore the domain of f is r minus 3 comma 3. Eighth problem, f of x equal to 1 by x square minus 2. So for f of x is belongs to capital R, x square minus 2 is not equal to 0. So this can be written as x square minus root 2 whole square is not equal to 0. So x square minus root 2 whole square can be written as x minus root 2 into x plus root 2 is not equal to 0. That means is not equal to x minus root 2 is not equal to 0 and x plus 2 is not equal to 0. From this, x is not equal to my plus root 2 and x is not equal to minus root 2. So therefore, here all the real numbers except to root 2 and minus 2. So x is belongs to r minus root 2 comma root 2. Next, ninth question, f of x equal to 1 by x square minus 3, x square minus 3. So f of x is belongs to capital R. So x square minus 3 is not equal to 0. So that means x square minus root 3 whole square is not equal to 0. So that is x minus root 3 into x plus root 3 is not equal to 0. So that means x minus root 3 is not equal to 0 or x plus root 3 is not equal to 0. X is not equal to root 3 and x is not equal to minus root 3. So therefore all the real numbers except to minus root 3 comma root 3. So therefore x is belongs to r minus root 3 comma root 3. So the domain of f is r minus root 3 comma root 3. Here also the domain of f is r minus root 2 comma root 2.